homework. Here we go. Second hour. All right, David, yes?
Yeah.
Aiden?
Yeah.
Ava? Lily? Avery?
No.
Sydney? Brayton? McKenna? Alyssa? Mia? Dylan?
No.
Toby?
Yeah.
All right, got all that recorded. So let's go over that real quick. All right, so let me see here. I should have my camera up. There we go. All right, so let's go over your homework. We had the first section here had to do with just kind of a review of ionic formula writing. Again, the ionic formula writing and the acid formula writing are probably the two most critical things that you have under your belt before you get into second semester. Okay. If you can't do these ionic formula writing and acid formula writing before you get into second semester, you are going to have a horrible time. Horrible. So make sure that you're making the time and the effort to get that taken care of. If you're still struggling with that, make sure that you are working through it, that you come in for extra help, that you get with another person, that somehow you figure out some way to master that material, because like I said, if you don't, you're going to have a really difficult time. All right. So look over your answers for those and let me know if you have any questions about any of the stuff. This is all ionic here. We'll get into acid at the bottom. And then today in class, you're going to learn to write the final type, which is covalent. All right, any questions on those top 18? Anything that doesn't make sense? Anybody still need the top 18 up because you're checking? All right. Then they asked you some questions. We had ionic bonds, and they are going to form between a cation and an anion. The crystal lattice is a 3D arrangement inside a crystal. It typically will give it more strength. When we're talking in terms of a molecule or a compound, typically that is going to be made up of alternating positive and negative charges, your cations and your anions. And that's going to lead it to have strength. How many oxidation numbers? Remember, the oxidation numbers are the charges. Representative elements are your S and P block elements. So those are the first columns, and then 13 through 18. And typically you only have one option there. The transition metals, though, you're usually going to have a lot of times more than one. So that like copper has a +1 and a +2 form, and iron has a +2 and a +3 form. And so those oftentimes will have multiple charges or oxidation numbers. Alloys, then, they're going to melt the metals, and then they're going to mix them with another element, and then they cool them. Steel, then, the interstices or the holes between the iron ore elements are going to be end up after they melt this, they're going to fill those holes with carbon, and that lends the strength and durability to the steel. Orbital diagrams, remember, those were the ones that used arrows, and with lithium, if it's lost an electron, all it has is its 1s electrons. The ratio of the cations to anions, well, this was both cations, so you couldn't do a ratio there. This one was a +2 and a -2, so you would have this in a 1-to-1 arrangement. Beryllium is a +2, nitrogen is a -3, so you're going to need 3 of these for every 2 of these. So that's where we got that. Here we have a compound X4. It's kind of small. Let me see if I can get that a little bigger for you. X4Y. And if we had 20 atoms of this, and this is in a 4-to-1 ratio, then if we scale that up, this would be in a 20-to-5 ratio. So we would have 5 atoms of that. Properties of ionic compounds, then, they tend to be brittle, they're dull, they have high melting and boiling points as well. Then you had some more cations and anions, and then finally your acid naming and formula writing. So let me know if you have questions about any of those, and I'll be more than happy to answer them, go through them, discuss them with you. All right, I see a lot of nodding heads, and it looks like everybody's winding down here. So today, we're going to learn our final type of naming and formula writing. And after all the stuff that you've been through, this is actually the easiest. It is so easy compared to what you've been through, okay? But we need to talk on Friday of this week. You are going to have a quiz. And that quiz is going to be over all forms of naming.
Pardon the interruption. Allison Biddick, will you please come to the attendance office? Allison Biddick, please come to the attendance office.
So it's going to be over all forms of naming, and it's going to be all mixed. So I won't say this is ionic, this is covalent, this is acid. Like, you've got to be able to figure out what that is. So let's talk about some clues that we could use to be able to figure it out, okay? So first of all, when we're talking about ionic compounds, you're always going to have a metal in the front and a non-metal in the back. Metal in the front, non-metal. And you can see from the names, they're going to be the same thing. So if this begins with a metal, you automatically know it's ionic. And those are the rules that you should follow. So the first question you ask is, does it start with a metal? If the answer is yes, then you're going to use your ionic rules. Does that make sense? If your answer is no, then it's either going to be acid or the things that I'm going to teach you today. So if your answer is no, it doesn't start with a metal, your second question is, does it start with hydrogen? If the answer is yes, then it's going to be the acid names, okay? Or if you're given this, does it have acid at the end? If it has acid at the end, that's a pretty good call that it's going to be an acid formula. That makes sense? Okay. So question 1, does it start with a metal? Question 2, if that is no, does it start with hydrogen or have acid in the name? If the answer is no to that, then you're going to go to the naming rules that I'm about ready to teach you. Okay, so that's the easy way to distinguish between the different types of naming. Okay, so when we are doing our naming, okay, and I've got a little bit better presentation, a little bit nicer looking presentation over here. Covalent naming, here we go. When we're doing this, okay, what you have to do is if both of the elements are non-metals and they don't begin with hydrogen, of course, because we've already got that eliminated. If they're both non-metals, then you're going to be following the rules for covalent naming. So the rules for naming these are you're going to first name the element in its entirety. So carbon or fluorine or oxygen or hydrogen or nitrogen. Just name it out, okay? The second name then is going to take the "ide" ending, which you guys are getting familiar with that. And then you're going to use prefixes to figure out how many atoms are present in each case, okay? Why is this not advancing? There we go. So let's look at some examples here. When we go through these, if you have more than one of the first element, you have to have a prefix. Oh, let's go back and talk about the prefixes real quick, okay? So prefix for one is mono, and I think you guys are probably familiar with mono being one. Di is two, so think about like divergent. It's diverging into two paths, or divorce. You take two people and break them into two. So di means two. Tri means three. You guys are familiar with like triangles, tricycles, that sort of thing. Tetra is a little more complicated, but have you ever played the game Tetris? Okay. So if you haven't, then you just got to remember it. If you haven't, go out and play it, and hopefully that'll help you. But with Tetris, what it is it's a game with these blocks, and it's always 4 blocks, and you've got to try to drop it in and fill the bottom section down here. So you might end up with your blocks being like all in a straight column, and you're filling that in that way. You might end up with 2 and 2 here, or 2 and 2 here, or here, or here. But it's always 4 blocks when you play Tetris. Let me see if I can find an image of Tetris out here. Images. Okay. So this is what that Tetris looks like. And when these blocks drop, they drop in a series of 4. So every time that they drop, you know, it may be like this, and you're trying to get all of these to line up. So this is going to slide down here, and then all of these will end up disappearing, and then you keep going with the game, and you lose when you can't fill these, you know, fill the whole board. So, but you can see from these Tetris that they're all blocks of 4 because tetra means 4. So that's why I bring that up, because for people, sometimes it's previous knowledge that you can use to remember that tetra means 4. All right. Penta means 5, and you're probably familiar with like pentagram, pentagon, that sort of thing. So that means 5. Hexa and hepta are a little more difficult for people, but here's how I tell you to remember the difference between the two. 6 has the letter X in it, and so does hexa. The other thing that you can do is this has more letters here than this, and 7 is greater than 6. So that's the other way that you can kind of try to help you remember between those. 8 is octa, like octopus or octagon. 9 is nona, and if you think about replacing these vowels with an I and an E, then it spells out the number 9. And then deca is 10, and if you think about like decade is 10 years. So hopefully that will help you with some of those prefixes. All right. If we are given a situation where we're given a formula and we want to name it, if there's more than one of the first element, we have to use one of those prefixes to tell people how many it is. So for example, here, this is di. That means that we've got 2 hydrogens. So dihydrogen. And again, this element gets spelled out like it normally does. This one, no matter how many you have to put a prefix in front of it, and it ends in "ide." So here, nitrogen, we would have one of them because there's no prefix. And then trihydride, this is hydrogen, we're going to have 3 of them. And so that's what your formula looks like. This is dinitrogen tetrahydride. So di means 2 and tetra means 4. Now, what do you notice about this formula that would never happen in an ionic formula? Other than, I mean, just with the numbers. Look at the numbers. Well, that doesn't matter. We're not talking about that. We're not talking about electrons. We're just talking about numbers here. Just look at the numbers. Think you're in math class. If you're dealing with an ionic compound, you would never have a situation where you would have a 2 to 4 ratio. Why? It would be 1 to 2. We would have the simplest ratio. In covalent, that rule is gone. It does not apply. I mean, glucose is, and you guys have had this before, it's C6H12O6. That is a covalent compound. Okay? This is glucose. You know that. You've had biology. You know that this is glucose. In an ionic compound, this wouldn't happen though. This ratio of 6:12 to 6. Okay? Because that's not the simplest ratio. The simplest ratio would be 1 to 2 to 1. Okay? So covalent compounds, you can end up with ratios that are not in their simplest forms, and that's okay with covalence. All right? So here, this is nitrogen. So 2 nitrogens you're going to have, and then 1 oxygen. So when you write that out, use your subscripts. And then here you've got 1 nitrogen and 1 oxygen. So that's what that looks like. And you guys are familiar with some of the stuff here, like carbon dioxide. So carbon dioxide, how many oxygens? 2. So that's your CO2. Carbon monoxide, how many oxygens? 1. Okay, so you've heard of some of this stuff like out in the real world. But anyway, that's it. That's as hard as it is. Now, how do you identify, if you see one of these, how would you quickly identify that you're going to use your covalent rules here? Well, the first thing that I tell you to do is look at the second word. If the second word in there begins with a prefix, automatically you know, you don't even have to think about it. If there is a prefix right here, you automatically know, boom, that is covalent naming. Okay? So when we get into a test situation or a quiz situation, the first thing you're going to ask yourself is it a metal? Or does it start with a metal? Let me say it that way. So first of all, does it start with a metal? If the answer is yes, then what type of bonding is that? Ionic. This is going to be ionic. Okay. If the answer is no, then does it start with H? In the formula, or acid in the name? If the answer there, and I'm going to have to go way down here, is yes, then use your acid rules. Okay. If the answer is a no, then it's covalent. Easy enough to identify those? Can you do that? Okay. All right. So I want to show you a couple more things. I had put some extra practice up on Google Classroom yesterday, but unfortunately the link in my grand scheme of life did not work. So I found today the actual, the valid link for this year, and I've put that here. So if you are still struggling with naming and formula rating, again, I cannot express to you the importance of being able to understand how to write these formulas out. It is so vital. If you are still struggling with that, this website is great because what you can do at this website is you can tell it what you want to practice. And you can tell it how many you want to practice. So you tell it how many you want. You tell it whether you want, you just want names and formulas right now. You guys should know how to do molar mass, and we're not really doing that in this unit. So just select molar or names and formulas. Then right now, you know how to do all of this. So start practicing it all. Or if you're still just struggling with acids, click off these and do your acids. Or if you're still struggling with ionic, click on that and do your ionics. Okay. So I'm going to just generate it for this. If you're still struggling with formulas, but you got the naming down, fine. Select one of those. Otherwise, mix and match. And then at this point, you should probably be doing the fill in the blank because really, honestly, unless you're really, really, really struggling, this is what you're going to have to do on a test is fill in a blank. If you're really, really, really struggling, then start with the multiple choice and work your way back to the fill in the blank. And then web page. So start. Hey there. Whenever you want to meet. Today I can meet third hour if you want, because I'm open third hour. So. Okay. Well, even if we get extra gift cards, we just have them in stock for later. So it's not a big deal. Yeah. Perfect. Okay. Sounds good. Yep. Bye. Okay. So here you're going to fill in the formulas. Okay. So iron phosphite. So this would be iron 2. So this is going to be Fe3. And then phosphite is PO. Phosphite would be PO3. And we would need 2 of those. Okay. And you can go through and eventually it's going to say, you can say grade it. And it's going to tell you what your score is. And I don't think that it lets you, it won't let you, but it'll show you in the end the subscript kind of formula for it. If you're stuck and you just want to like get the answers, all you just have to do grade it. And it's going to give you all the answers to everything here. And they have so many like combinations of this and options and everything that you could spend days and days and days at this. Okay. But if you're still struggling, this is a great place to go and get help. Okay, make sense? All right. So for today, for homework, you're going to have 8-1, which should take you maybe 5-10 minutes max. Now, a couple of the questions that come up with that is if we get a situation where we have double vowels. So for example, if we had, like here, we've got monoxide, they usually drop the second vowel. So this one, you would have mono and you would have oxide coming together. So you would drop one of those vowels. You wouldn't have a double O. All right. I also, if you double a vowel like that, I'm not going to mark it wrong. Okay. I want to see the prefix. I want to see the anion or the anion in here, or the element in here. And I want to see that it ends in "ide." Okay. That's what I'm looking for. If you double a vowel up on me, I can deal with that. Okay. If you don't get the prefixes right, or you don't get some of this other stuff right, that I can't. But if you double a vowel up, that's the least of our worries right now. Okay. So today, what I want you to do is I want you to finish your homework. Then if you want to do another one of those quizzes, if you want to, I've got version 3 up here. If you need that, you're more than welcome to take that. And then work on some extra practice if you're needing that. Okay. So that kind of gives you a guideline, a timeline ideas for what we're doing.